So we are going to solve the following rational inequality. We are going to graph it on a number line and express our solution in interval notation. So the first thing when solving a rational inequality, so it kind of wants you to ignore the fact that it's an inequality at first, and we're going to treat it as if it's an equation and just set it equal to 0. But then the next step of solving this actually says that in order to solve a rational inequality, what we want to do is we want to make sure that our problem is, or all of our terms are on one side of the equation into a single fraction. All right, so we currently already have that. Everything's on the left-hand side, set equal to 0. We have a single fraction here. So just real quickly here, if we had maybe this problem, for example, we would not be able to move to the next step yet because we have two separate terms. We would have to get common denominators and join these two into a single fraction before being able to move on to the next step. But once we have everything into a single fraction, the next step actually says separate the numerator and the denominator. So take what's in the numerator, right? Separate that. Take what's in the denominator, 3x plus 1, and set them each equal to 0 and solve. So solve these two equations. So subtract the 4 on each side. So drop down the negative 2x, and that's now going to equal a minus 4. Divide each side by negative 2, and x is equal to a positive 2. Pause there while you solve the other one. So subtract 1 on each side to get 3x is equal to a negative 1. And divide out your coefficient to get x is equal to a negative 1/3. Now these solutions are known as boundary points here. So let's say we're looking at our line graph here, and we have a 2 and we have a negative 1/3 there. So we do have these boundary points. Our next step in the process, though, is to figure out where our solutions are. Remember that this is an inequality, so our solutions are going to be a range of solutions, like greater than 2, less than a negative 1/3, or something like that. So we need to figure out exactly where here we are shading. So in order to do that, so there's a couple of different ways that you can do that. So some people like to take a value in each one of these intervals. So something on this left interval, something between these 2 points, something on the right-hand side, and test those. What I like to do is I like to pick the interval that has a 0 in it. So 0 belongs right here between a negative 1/3 and a 2. And I like to test that area. If I plug in 0 to the original inequality here and it works, I know I'm going to shade this section. But if I plug in 0 and it does not work, that means I would not shade here, but I would shade the sections on the other sides. So let's go ahead and plug in 0. So if I plug in 0 into our original inequality here, so that's going to look like, let's see, 4 minus a 2 times 0 over 3 times 0 plus 1. Is this less than or equal to 0 here? Well, let's see. So that means this is going to be a 0, and this is going to be a 0. So we really just have a 4 up top and a 1 down bottom, which is just 4 is less than or equal to 0. Now, 4 is not less than a 0. This is not true, which means that this interval, this section here, does not work for us. That means we are going to shade either direction here on these sides. So our next step in order to write the interval notation for this problem here. So one important thing that we got to remember, because we're working with a rational inequality, keep in mind that a fraction cannot have a 0 in the denominator. If you have a 0 in the denominator, it is undefined. So the solution, the boundary point that we got when setting the denominator equal to 0, right? So our denominator is 3x plus 1. And when we solve 3x plus 1, we got negative 1/3. That means that this negative 1/3 is always going to have an open dot. When we do interval notation, it's going to have a parentheses. But this 2 over here is going to have a solid dot here. All right, so remember, if you could equal it, it is going to be a bracket, which is also a solid dot. But your denominator will always have a parentheses, have an open dot there. So our interval notation coming from the left-hand side, parentheses always for infinity, right, because it's coming from the negative infinity direction, up until the negative 1/3, close your parentheses. Then you have a gap here, so you're going to represent that with a union. And then we pick our answers back up here at a 2, and that's going to have a bracket with a 2, comma, all the way to a positive infinity, which has a parentheses.